Okay, I was gonna make a video for the final exam questions. So I thought about it, I made one and actually messed it up. So in case I mess up in the middle of the video, I decided to make a video for each question. So that way every video is really short. So if I mess up, I can always start over. Let's start with the first question. The first question is calculating a limit. So with the limit calculation, we mentioned that in chapter 1, there are three methods. You can calculate limit with numbers. For example, this question, you can make x equal to 0.99. So you calculate 0.99 squared plus 0.99 minus 2 and find out the number. And then you calculate 0.99 squared minus 1 and find out that number. And you divide these two numbers. That'll give you a numerical calculation. It will not be exactly the right answer, but it will be really close. So using number allows you to mimic that process of x approaching 1, and therefore mimicking the process of function value is approaching the actual limit value. And that's when you have not a lot of idea, when you are a little bit lost on how to calculate the limit, you can always use a number. There are also question about x approaching infinity. If x approaching infinity, all you have to do is making x equal to a really large number, like x equal to 1000, to find out the limit of a function when x approaching infinity. So those are options when the function is very complicated. You want to find the limit of the function using numbers. Now, this first question is not a overly difficult question because the coefficients are 1 and 2, x is approaching 1. So we actually have an elliptical method. With all limit calculation, you can do it with numerical calculation. You can calculate it with a graph of the function, or you can calculate it analytically. In our class, we focus on the analytical method. So there are two methods you can use to solve this limit calculation. The first one is L'Hopital's rule. In section 4.2 of the book, we talk about L'Hopital's rule. That is, if you want to find the limit of a function, and this limit calculation, suppose it's difficult, you make x equal to 1, and then 1 plus 1 minus 2 is 0. In the denominator, 1 squared minus 1 is also 0. So when the limit calculation cannot be solved by substituting the limit value, and that's when you have to apply other ways. L'Hopital's is one of them. It handles 0 divided by a 0 situation like this question. This question, when x equal to 1, the numerator equal to 0, the denominator equal to 0, and therefore substitution failed. So what do we do? According to L'Hopital, this kind of limit calculation can be solved by finding the derivative of the numerator and then find the derivative of the denominator. In this case, numerator have x squared plus x minus 2. The derivative is 2x plus 1. The denominator is x squared minus 1. The derivative will be 2x. So now you see L'Hopital does not solve the limit calculation, allows you to write the limit calculation into an equivalent one that may be easier to solve. So it's reduced level of difficulty. So now we have to solve this limit calculation. This one, if you make x equal to 1, you see in the denominator 2x. If x equal to 1, that's 2. In the numerator, 2x plus 1. When x equal to 1, that's 3. So the answer to the question, substituting x equal to 1, we find out the limit value. That is 3 over 2. So that's how you can solve this question with L'Hopital's rule. That's one of the methods. The method that we were using in chapter 1 before we learned L'Hopital was factoring. So another method would be looking at this limit calculation, thinking about why would the polynomial equal to 0 if x equal to 1? When x equal to 1, polynomial in the numerator equal to 0, polynomial in the denominator equal to 0, because x minus 1, 1 minus 1 equal to 0. So we know the numerator and denominator both has x minus 1 as a factor, and we try to factor it. It turns out that's right. That's right. Numerator factor into x minus 1 times x plus 2. Denominator factor into x minus 1 times x plus 1. This you can factor. The factor, I hope that you had some of the practice of factoring in college algebra. Now we realize numerator and denominator have a common factor. In spirit of trying to simplify it, we'll cancel the common factor. Now we have this. So the long process is we still have not calculated the limit. We're trying to reduce the level of difficulty to make the limit a little bit easier for calculation. Now, after cancel x minus 1, in the bottom line of this calculation, when the x approaching 1, numerator is 1 plus 2, denominator is 1 plus 1. There's no issue. There's no 0 divided by 0 anymore. So this calculation can move on and calculate it. We got 3 over 2. So this is solving the limit calculation using factoring. And this is one of the examples showing that you can have different methods of solving the same calculation. You can do it numerically, do it with factoring, do it with L'Hopital. Of course, you can also do graphing if your calculator have that capability. But most of us focus on the calculation rather than the graphs. All right, so that's the first example on the final exam.